Hello viewers, today's topic is plate tectonics. The theory of plate tectonics states that the Earth's outermost layer is fragmented into a dozen of large and small plates that are slowly moving relative to each other. The continents have not always been arranged like they are today. According to the hypothesis of the Alfred Wegener, which was proposed in the 1912, some 225 million years ago, all the earth was together and it was called as a supercontinent or the Pangea. That means all the earth. But it began breaking in the geological past. Some 200 million years back, the supercontinent Pangea break down into the two large parts. The one was the Laurasia and another was the Gondwana. The Laurasia land, it contains the northern part of the land that consists of today's North America, Europe, Asia, while the Gondwana land, it consists of today's South America, Antarctica, Africa, India, and Australia. To understand plate, it is necessary to understand the internal structure of the Earth. Earth is not a homogeneous mass, but it is layered structures. Mainly, it is divided into the three layers. One is crust, another mantle, and the core. Crust is the outermost and the thinnest layer of the Earth. It is relatively cool and consists of hard rock. There is two types of crust. One is continental crust and the oceanic crust. The continental crust, which is under the land and under the huge mountains, this is thick, less dense than the oceanic crust and mostly old. And the thickness of this crust is around 32 km under the continents, and this depth may go up to the 70 km under the mountain. It mainly consists of the granite. That means the chemical composition is like the composition of the granites. The oceanic crust, that is the thin, dense, sink under the continental crust, and it is believed that it is relatively younger than the continental crust. It is about some 3 to 5 kilometers or to 8 kilometers thick under the ocean. The average composition of the oceanic crust is basalt. The second layer of the earth, that is mantle. Again, this mantle can be divided into the upper mantle and the lower mantle. The thickness of the lower mantle varies between 35 km to 2900 km. The average density of the mantle is 4.5 gram per centimeter. The upper portion of the mantle and the crust together forms the lithosphere, while the lower mantle, this is termed as asthenosphere. Now the third layer of the earth, that is core, which is again divided into the outer core and the inner core. That is molten in the states. Depth varies from the 2900 km to 5150 km. Density is around 10.7 gram per centimeter cube. It is believed that the innermost core is solid in state. Temperature is very high. The total depth of the mantle core varies from 5150 km to 6371 km. The average density is 15 gram per centimeter cube. Now, as we discussed earlier, the upper portion of the mantle, which extends from crust to the mantle boundary down to a depth of some 350 km, has two zones. The lower portion of the upper mantle is called as the asthenosphere. The thick and rigid lithosphere is floating over the asthenosphere. To understand theory of plate tectonic, it is very important to understand the lithosphere and the asthenosphere. Lithosphere can be as thin as 10 km where two plates are separating, and it can be as thick as more than 100 kilometers under the mountains. The thick and rigid lithosphere is floating over the asthenosphere, which extends up to 350 km to 400 km under the earth. The boundary between this depth, at the boundary between asthenosphere and the lithosphere, there will be the gradual increase in the temperature. At asthenosphere, at the depth of approximately 100 kilometers, rocks are at their molten form or they are very near to their melting point. This asthenosphere-lithosphere boundary is responsible for all the type of volcanic activity or for the earthquake or whatever the changes we are seeing at the earth's surface due to the internal forces. Because of the convection cells, asthenosphere is moving slowly. Because of the movement of the asthenosphere, the lithosphere, which is riding over the asthenosphere, is also moving. Now, it is believed that the earth is not in the static form, it is continuously moving. The continents have not always been arranged like they are today. The earth crust is divided into the segments, which is called as plate. The theory of plate tectonics states that the earth's outermost layer is fragmented into the dozen of large and small plates that are moving relative to one another on the top of the mobile asthenosphere. Asthenosphere means less strength zone. It is believed that the asthenosphere is moving over which the lithosphere is floating. If we consider a plate which is the part of the crust and the upper mantle, which is approximately 100 km thick, this is called as plate. Plate is a large mobile slab of rocks which is bounded by the weak planes or the surface. Now question arises why these plates are moving. It is believed that the generation of convection cells within the mantle is responsible for the movement of these plates. Because of the huge temperature difference between the outer core and mantle, it's responsible for the generation of these convection cells. From the base of the mantle, the hot molten material, which is termed as the magma, rising up, and the cool magma is sinking down. This process is very continuous, which is responsible for the all type of plate movement in the earth's surface. Here we can see hot material is rising up and cool magma is sinking down. Now by this process, three types of plate movement is possible. That the type of plate movement is depend upon the plate boundaries. Plate boundary refers to the border between the two adjacent lithospheric plates. Usually they are classified by their relative movement. It may be converging type, it may be diverging, or it may be the transform boundary. Here we can see this is the region from where the magma is upwelling, magma hot mantle material is coming up. So because of this upwelling of the magma, two plates are moving away from each other. In this region, because these are the convection cells, in this particular region, two plates are coming towards each other. And there are some transform boundary where two plates are moving past each other. This plate movement can understand well with the help of the Engg diagram. Divergent plate boundaries where two plates are moving away from each other. That means there will be the thinning of the crust and upwelling of the magma. Now two plates are moving away from each other. Convergent plate boundaries, two plates are coming towards each other. These two plates both may be the continental plates, or one may be the continental plate, another may be the oceanic plate. One continental, one oceanic, both of the oceanic, both of the continental may be the possibility. These are the transform plate boundaries where two plates are moving past each other. Again, the diagram of the divergent plate boundaries, convergent plate boundaries and the transform plate boundaries. This is the typical diagram of the divergent plate boundaries where plates are moving away from each other. Hawaii Island is the typical example of this boundary. This is the Pacific Ocean and this is the upwelling magma. By the upwelling of this magma, a mound or the island may be formed. But because this plates is moving away from this source, so after some time, this island may move up to here, again up to here, and finally it may submerge. If we will see the aerial view or the satellite view of the Pacific Ocean, we can find out so many small islands over here. If we will go for the aging of these continents or the carbon dating we will do, then we will find that this is the youngest in the age, while the island which is far away from this moving plate is the oldest. That indicates that this island has moved from this source. Now after some time, this Hawaii Island will again move and this place will be occupied by some new island which will be formed by the continuous upwelling of the magma. Now example of the convergent plate boundary. The excellent example of the convergent plate boundary is the collision of the Indian and Eurasian plates. The feature associated with the convergent plate boundary is the compression. And as we know, when we have the compression, we will get the reverse fold and there may be the creation of the subduction zone. Now, which plate will subduct under the another? It will depend upon the density of the plate. Suppose we are having one continental plate and one oceanic plate. Because oceanic plate is heavier, so it will subduct under the continental plate. And the mountain building is the best example of the convergent boundary. Entire Himalayan range is the product of the convergent plate boundary. Here we can see the convergent plate boundary. So entire this zone extending from the Jammu Kashmir up to the Arunachal Pradesh, this entire zone is known as the convergent zone or the suture zone, where two plates are colliding with each other. Because both of these are the continental plate, so they may change into the mountain. If it would be one oceanic and one continental plate, then there may be the possibility of creation of the subduction zone. Now the divergent plate boundary. Divergent plate boundaries are associated with the following. Tension or the extension means where the two plates are pulling apart from each other. So as we know, when we have the extension type of environment, we will get the normal fault and the rifting. And if rifting is there, that means the crustal thinning will be there, and these will be the site for the upwelling of the magma. The typical example is that this is the Red Sea, Arabian plate and African plates are moving away from each other, and there is the creation of the Red Sea. So it is believed that after some time, some geological time, there will be the widening of this sea, and possibly this entire zone will rupture, and then there will be the extension of the sea. We have example here, North American plate and Eurasian plates are moving away from each other, and we may get the creation of this large sea. The third type of boundaries are the transform boundaries. These are associated with the horizontal grinding motion, strike slip faulting, and lateral offsetting of the rock unit. We can see here the lateral offsetting of the rock unit, and this type of plate boundaries are of very large scale, and typical type of fault which will develop in this environment is transform faults. Now the faults and the plate boundary, as we have already discussed, if we have the extension type of or the tension type of environment, we will get the normal fault, and the plate boundary will be, that is the divergent plate boundary. If we have the compression type of environment, we will get reverse fault, and we will get the convergent plate boundary, like the example is the Himalaya. If we have the shear type of movement, then we will get the slip fault or the strike slip fault. Thank you.